Okay, so I'm going to go over our notes from today. Which families make up the S sublevel? That is the alkali metal and the alkali. Okay, and which families make up the P sublevel? Remember, that's the boron, carbon, nitrogen, oxygen, halogens, and the noble gases. What is the name of the group that makes up the D sublevel? That's the transition metals. Remember our three rules. When writing electron configurations, it is written from the lowest energy to the highest level according to the Aufbau principle. This is called the longhand or ground state configuration. Then we're going to write the electron configuration for sulfur. Going straight across the periodic table, we always start with 1s2, 2s2, 2p6, 3s2, 3p4. Then niobium, that's going to be all the way in the 4d3 here. So 1s2, 2s2, going straight across the periodic table to 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and 4d3. Shorthand configuration. This is to write the shorthand configuration, put the noble gas in brackets, which comes before the element, then complete the configuration. So if we look on our periodic table for oxygen, here's oxygen. We know that helium comes before, then we just complete it, 2s2 and 2p4. For iron, argon is our noble gas, and then just complete the the configuration. 4s2 and 3d6. Tellurium. Here. Krypton is our noble gas before, so we put krypton in brackets, and then 5s2, 4d10, and 5p4. So I asked you to practice on your own today, going over these. So carbon, helium is our noble gas before carbon, and then 2s2, 2p2. Nickel is argon, 4s2, 3d8. Indium is krypton. So if indium is here, we look here, krypton, 5s2, 4d10, and 5p1. Then we learned our orbital diagrams. If I'm going too fast, pause the video, try these, and then continue. To draw the orbital diagram, we will use the shorthand configuration. We use boxes for the orbitals and arrows for the electrons. Remember, according to the Pauli exclusion principle, there can only be 2 electrons in any orbital. When there are 2, they must have opposite spins. Remember, according to Hund's rule, each orbital must have 1 electron before they pair up. If there are only 2 electrons in each sublevel, they have opposite spins. So let's look at one. Okay, so let's look at oxygen. We have helium in brackets, and then the 2s, S has 2 electrons, and the Pauli exclusion principle says I have 2 electrons in any one orbital, so 2 divided by 2 gives me 1 orbital, and then P, we have 1, 2, 3 orbitals. So this number, the superscript, is going to tell me how many electrons. So I have 2, and they must have opposite spins. Then P4, 1, 2, 3. Hund's rule tells me I have to have 1 in each orbital before pairing, and I come back and pair. Okay, so this was oxygen. Now let's look at Te. We're going to put krypton in brackets. Then we have 5s, 4d, and D is going to have 5 boxes, and then 5p. Okay, so S2, 2 electrons in each orbital, and then D10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then 5p4, 1, 2, 3, and then pair. Oh, that's a mess. Let's do another one. Argon. So we have, iron will be argon, And then 4s has 1 orbital. 3d, D is going to have 5 orbitals. So the 2 tells me that there's 2 electrons in each orbital. We have to have opposite spins, and then I have 6 electrons in the D. 1, 2, 3, 4, 5, and last but not least 6. Okay? If you have any questions, be sure and email me.